Okay, so this problem is also in your notes. I've tweaked it a little so that it kind of separates the pieces of work that you'll have to pay attention to. It reads, suppose the price at which X calculators can be sold is represented by P of X equals 100 minus 0.01X, and the cost function or the amount spent to manufacture X calculators is C of X equals 50X plus 10,000. And it says find the profit equation. All right, so to be clear, this is not profit, this is price. This is the amount of money that you slap onto your calculators in order to sell them. Your cost, also not profit, this is the amount of money that you spend in order to make your calculators. All right, so we have to go back to an earlier discussion that we had. And in order to profit, you have to think about the revenue, which is the money that's coming in from sales, and your cost, which is the money going out from expenses, right? So both of those two things have to be taken into consideration. So let me write this down. Sales, I want you to see that, and then cost is the money going out from expenses. Okay, so then your profit is what you have when you take everything that you have coming in from your sales and you subtract off with all of your expenses. So I'm going to go over here and I'll write that profit equals the revenue minus the cost. All right, so they gave us the cost equation. There it is. So 50 plus, 50x rather, plus 10,000. That goes there for the cost equation. And then your revenue, we got to be careful because this is price. This is not revenue. In order to get the revenue, then you take your selling price and multiply it by X. Okay, so let me write that down up here. Revenue equals your selling price, that sticker amount, times however many of these you sell, or your quantity, right? So in this case, R of X is going to equal, well, you've got a sliding scale, right? So 100 minus 0.01X, and then how many calculators selling? Well, there's X calculators that are selling. Okay, of course, you could take that one further by distributing the X throughout. So then your profit here, give me a second, I'll shift this. Okay, is going to equal this revenue equation that we have. I'm going to distribute the X. So 100X minus 0.01X squared minus your cost equation. All right, so I typically don't simplify that, but I notice that most students do like for that to be simplified before they move on. So 100x minus 0.01x squared minus 50x minus 10,000. Okay, so if you have to go one further, by all means, please do. You can combine these two. Both of them are x terms. So negative 0.01x squared plus 50x minus 10,000. Let me show you that. Okay, so here we go. In order to maximize or minimize anything, we have to keep in mind that if this is our profit equation, right here at the top is where you're getting zero slope, right? You should have a horizontal tangent line. And if your profit looks like this, then right here at the bottom, your minimum is also where you get zero slope. So in both cases, whether you have a max or a min, you should end up with zero slope in those spots, right? Zero slope at the max and zero slope at the min. So the process of finding your max and your min should be exactly the same. So here we go, step one, and I'll write them all down this time. Take the derivative. So P prime of X then equals the derivative of this term right here is negative 0.02x plus 50. There's step one. Step two, you set your derivative equal to 0. So let's get to that. Negative 0.02x plus 50 equals 0. You'll notice I don't carry this label because it becomes confusing. You don't need it. All you're trying to do is solve for the x. And then step 3 is to solve for your variable. Right? So, I don't know, you could add 0.02x to both sides plus 0.02x, and you get 50 equals 0.02x. Please show all of the work. Divide by 0.02, divide by 0.02, and I can't do that in my head. Let's see. And I got 2,500. So from all of this, I get that x equals 2,500. So over here, where it says x equals, I'm going to put 2,500, but I need units. So I gotta go all the way back to my beginning and say, oh yeah, it was calculators. So make sure you're writing that because as you know, I am particular. Calculators. Okay, so then your selling price. Once you get this 2,500, everything else is plug and chug. So I had to go back up and say, where's my selling price function? And they gave it to us at the very beginning. It's right there. Right? So down here in my work, I'm going to put that P of x is 100 minus 0.01x. So then P of 2,500, right? I'm acknowledging that I'm finding out what happens at a specific point. Or specific x value rather. Let me find that real quick. 100 minus 0.01 times 2500, and I got 75. So this is 75, and their selling price is in dollars. And then the last thing it says is find the maximum profit. Okay, so your profit is not found by taking the quantity times the price. So please don't do that. That's going to be revenue. Your profit function is right up here, right? Any of these derivations will work. So you can go back into this equation and plug in your 2,500. Okay, so I'm going to write this equation right below. You guys should have written it down yourself. So here we have that the profit equation equals negative 0.01 x squared plus 50x minus 10,000. And we want to find out what happens specifically at 2,500. Minus 0.01 times 2500, the quantity squared, plus 50 times 2500 minus 10,000. Okay, let me scoot that over so you can see. So that too is going to be in dollars. All right, I'm going to allow you guys to find that number. I might be able to do it if I don't run out of time on this particular camcorder. All right, so we need to show that you've maximized it. So here's the problem. Let me go back up here. When you do these 3 steps, take your derivative, set your derivative equals 0, solve for your variable. As I showed over here, you could get a max, but you could also get a min. So what your number line does is it weeds one of these out, right? So we're going to go here on your number line. You notice you have 3 numbers now that you could consider, but you're always going to put on your number line whatever came out when you did your derivative, set your derivative equal to 0 and solve for your variable. So notice that's 2,500. So down here, I want to do 2,500. Make sure you use reasonable numbers on your number line. Let's see, you could do 1. Don't do a negative number because you can't have negative calculators. And here, 3,000. Okay. And over here, my label. I'm now going to see what my first derivative of my profit tells me about my original function. Again, you're trying to maximize the profit. So you're trying to use your first derivative test on P. All right, so let's put the work over here. Kind of running out of space. But let's see. We know from earlier that P prime of x equals negative 0.02 x plus 50. How do I know that? Let me show you. Right there, when I took my derivative, that's what I got. And we want to find out what happens at 1. Negative 0.02 times 1 plus 50. And I can tell you that is positive 49.98. So positive there. And we also want to find out what happens at 3,000. So negative 0.02 times 3,000 plus 50. All right, give me a second so I can plug it in. So negative 0.02 times 3, 1, 2, 3, plus 50. Again, if I've made a mistake in these videos, just send me an email. I'd be more than happy to correct it. I am human, so I do err. So I got negative 10. So negative here. All right, so let's think about that, what that means. If your slope of your tangent line is positive, it means your line looks like this. Right? That's what P looks like. Okay, this says if the slope of your tangent line is negative, it looks like that. So this means that you're looking at a local max. And that's it. That's the entire problem.